Your phone buzzes on the table beside you. You haven't even looked at it yet. But your heart rate has already changed. Your palms are slightly damp. Somewhere deep in your skull, a tiny almond-shaped structure has just fired off a silent alarm. You glance down. It's just an email from your boss. But the real answer to why your body reacted that way is far stranger than you're stressed about work. Your brain doesn't know the difference between an email and a predator. It never learned to. For most of human history, there were no inboxes. There were no red notification bubbles. There were only two kinds of mornings, the ones where you found food, and the ones where something tried to eat you. Your nervous system was built for the second kind. And it has never been updated. Walter Cannon, the physiologist who first described the fight-or-flight response back in the 1920s, noticed something simple but unsettling. When an animal senses danger, its body doesn't wait for permission. Blood rushes away from digestion and toward the muscles. The heart speeds up. The lungs open wider. Pupils dilate. The entire system reorganizes itself in under a second, before the conscious mind has even finished forming the thought, what was that? This wasn't a flaw. It was the whole point. A zebra that pauses to think, is that really a lion, or just tall grass moving in the wind, is a zebra that gets eaten. The animals that survived were the ones whose bodies reacted first and asked questions later. You are descended from the ones who reacted first. Every single one of your ancestors, going back hundreds of thousands of years, had a nervous system that treated uncertainty as danger. Because on the savannah, uncertainty usually was danger. So what happens when you take that ancient alarm system and drop it into a world made of glass screens, traffic lights, and group chats? Robert Sapolsky, a neuroendocrinologist who spent decades studying stress in wild baboons, found something striking. In the animal kingdom, stress is almost always short. A predator appears. The body activates. The animal runs, fights, or escapes. And then, within minutes, it's over. The zebra goes back to grazing like nothing happened. Humans are different. You can lie awake at 2 a.m, replaying a conversation from 3 days ago, and your body will respond as if that conversation is happening right now. As if the danger is still in the room. Your heart doesn't know it's a memory. Sapolsky's research showed that this is precisely why humans suffer from stress-related illness at rates far higher than almost any other animal. Not because our lives are more dangerous. Because our alarm system never gets the all-clear signal. It just keeps running. Here's where it gets stranger. Your amygdala, the small almond-shaped region Cannon's work eventually led scientists to study in detail, doesn't just respond to physical threats. Neuroscientist Joseph Ledoux spent much of his career mapping exactly how this structure works, and what he found was unsettling in its simplicity. The amygdala can't tell the difference between a snake on the path and a snide comment in a meeting. To your amygdala, both are just threat detected. Both trigger the same flood of cortisol. The same tightening in your chest. The same readiness to run from a room that, physically, you are in no danger of dying in. Have you ever felt your face get hot after someone criticized your work in front of others? That heat is the same biological response your ancestors felt when they heard a branch snap behind them in the dark. Your body is preparing you to fight or flee from a sentence. Now think about how many of those moments happen in a single day. A red notification. An unanswered text. A slightly cold reply from a friend. A traffic light that won't change while someone behind you taps their horn. None of these can actually hurt you. Not one of them is a lion. But your body doesn't know that. It activates anyway. Again, and again, and again, dozens of times a day, in tiny doses too small to notice individually but large enough, over years, to wear down the very systems meant to protect you. This is what researcher Bruce McEwen called allostatic load, the slow, cumulative cost of a stress system that never fully shuts off. Not one big crisis, but thousands of small ones, stacking quietly, year after year. Your ancestors faced real danger maybe a few times a week. Maybe a few times a month, if they were lucky and lived somewhere safe. You face it dozens of times before lunch. And here's the part that should make you pause. The lion was honest. It showed up, the danger was real, and then it left. Either you survived, or you didn't, but either way, it was over. The modern world doesn't work like that. The email doesn't leave. It sits in your inbox, unanswered, for hours. The argument doesn't end when you walk away from it, it follows you home, replaying in your head at full volume. The social comparison doesn't disappear when you close the app, it lingers in the background of your thoughts for the rest of the day. You are surrounded by threats that never fully resolve. And your body, the same body built over millions of years to handle a world of short, sharp, resolvable dangers, has no idea what to do with a threat that simply doesn't end. So it stays switched on. Slightly elevated heart rate. Slightly shallow breathing. A low hum of tension in your shoulders that you've stopped noticing because it's been there so long it feels normal. Is that hum normal, though? Or is it just familiar? There's a difference. Think about the last time you actually felt completely calm. Not numb. Not distracted. Calm. Can you remember when that was? For most people, the honest answer is unsettling. It's hard to remember. That's not a personal failing. It's not a sign that something is wrong with you specifically. It's the predictable result of putting a Stone Age alarm system inside a 21st century life, and then asking it to work overtime, indefinitely, with no lions in sight and no all clear ever sounding. Your nervous system isn't broken. It's just doing exactly what it was designed to do, in a world it was never designed for. Which means the goal was never to silence the alarm completely. You can't. It's older than language, older than fire, older than the species you belong to now. But you can learn to recognize it for what it actually is. The next time your chest tightens over a text message, or your stomach drops at a notification, try noticing it for what it really is, an ancient survival reflex, fired by a brain that is still, on some level, scanning the grass for movement. It's not weakness. It's inheritance. Your great-great-great-grandparents' fear is still living in your body, still doing its job, just aimed at the wrong things now. So tonight, when your phone buzzes on the table beside you, and your heart rate changes before you've even looked down, you'll know what's really happening. It's not the message. It's the lion that was never there.